Good morning, Year Fives. It is, what day is it? Wednesday. And it is another drizzly day. But you know what? I quite like the drizzly day. It means my veg are getting watered. It means my whole garden is getting watered. And I've noticed that there's been more birds around. So it must be making it easier for them to find the worms. Right. Maths first. Let's have a look at our do nows. So, this is a tasty angles question. You know what? I'm going to do that one last today. So let's have a look at the other bits first. So our multiplying, dividing, and our rounding and estimating. Ooh. Right, so very quickly then, these should be done in your sleep now. So the 0 there, times it by 10, so move the decimal. So that should be 567. Divided by 100, 2 zeros there. So boom, boom, 1, 2, so that should be 0.324. Obviously that would be 32 pence, wouldn't it? So you could just do that. And then 2 zeros. Remember, there is no decimal. Well, there is a decimal point, but it's a whole number, so you just don't see it. So write the number out, and then boom, 2 zeros, and then you've got to work out where the comma goes. 555 round to the nearest 10. So don't forget. So ones, tens, hundreds. Nearest 10. Let's look at the 10. And the one before it, where it's 55, so the nearest 10, rounding up, that's going to be 60, so that's 560. Nearest 100, right, let's have a look at the 100, that's a 5. Let's look at the one before, it's a 10, that's going to round up. So that's going to go round the hundreds up to the next number, which is 6, so 600. And then 1,000, we look at the thousands, there's no thousands there, but let's look at the place value before, which is a 5. 5 rounds up, ticks everything else up. So from a 0, that goes up to 1. So the nearest 1,000 is 1,000. So my handwriting's gone awful here because it's right on the spine of the notepad. 87 times 53. Don't forget one estimate here, so I might round that one to 90, that one to 50. Get rid of the zeros. 9 times 5 is 45. Get the zeros back on. 4,500. Boom. 2,205 times 12. Ooh. So, we could go 2,000. We could go 2,000, couldn't we? Times 12. So, get rid of our zeros just as before. 12 times 2 is 24. Bring our zeros back on. 24,000. There you go. Hopefully you realise that those two link very closely. If you round, you're rounding. Sorry, not that one. That one with these ones. You're rounding with your estimating. Next week, especially when we potentially keep an eye out for some of those because they get a little bit trickier. Right, let's have a look at our angles. We've been doing angles now for a good couple of weeks in our do nows, and we've had it as a few activities. Remember, the next few days, I'm trying to give you ones that look absolutely petrifying, but I'm proving to you that if you know the basic rules, then you just find somewhere to start. And the trick is finding somewhere to start. So the task is that. So I've drawn it out the same. So you get told that this is a rectangle. You get told that this is an equilateral. If you ever get told that in a question, fill in what you know. A rectangle is 90 degrees. Okay, and if you really want to, you can write it as well, just so it's a bit visual. We get told this one's an equilateral. You should know by now that means these are 60. Okay, I hope you can see that. Oh, hang on a minute then. There's actually hardly any missing angles here. We've got all these full. We've even got given this one here. We've got this one here. We're only actually missing... Well, the only one we need to find is this one here. The only thing we need here is this one, and then we can complete the 360. So to find that one, we need to know what this one is in the triangle. And as if by magic, we've got something on a 180 degree line. So we need to find this one first. So 117 up to to finish the straight line to 180, 17, 27, 37, 47, 57, 67, 77. So that's going to be 63. See what those two make. 8, 9, 10, 11, 6, 13, 131. So whatever's left for 180 is going to be this one here. 31, 41, 51, 61, 71. That's going to be 49. That didn't sound right. Yeah. Yeah, that's right. And then you've got everything you need. You've got yourself a full turn, a circle here, 360. So you've got 109, 60, 49. I've missed one out. Oh, and 90. 1, 2, 3, 4. Right, 9 and 9 is 18. Can you still see my calculation? It's right at the bottom. There we go. 9, 9 is 18. 9 is 6 is 15. Add 4 is 19. Is 20. 1 and 2 is 3. So we know a full turn is 360. So 108, 18, 28, 38, 48, 58, 52. So the missing angle is 52 degrees. Well done if you did that without the video. I'm proving to you that even if something looks ridiculous, you've got all the information. I love angle questions. All the information is given to you. You just need to find where to start. Right, on to the next part, our task for today. So, scroll down. You'll recognise these. We've done these before. I've added a few new ones, but we did these before in some of these in class, or it might have been as homework. I can't remember. It might have been as homework. So, you definitely had the first couple before. As I gave you as a tip, sorry, all these are equivalent to each other. So they're all out of 100. So 0.4 is 40%, which is 4/10, which is 40 hundredths. It's whatever you think is useful for this question. So Dave has 0.4 of the cards handed to him. Sam has 12 hundredths of the cards. What percentage of the cards were still on the table? Well, first of all, we need to decide what we're working in. Do you want to work in decimals, percentages, fractions? For this one, it doesn't particularly matter. The answer you want is in percentages. You might want to change them to percentage. 12 hundredths, 12 out of 100. Percent is per 100, so that's going to be 12%. 0.4 is not 4, it is 40, remember, so that is 40%. So 40% and 12, so that's 52. So there's going to be, you've got 52, you need to be out of 100, so what's left? 48%. 99% of sea turtles don't survive. Show how many survive in a fraction as a decimal and as a decimal. So 99% don't, which means 1% do. So what's 1%? But that's too easy. So what's 1% as a fraction or a decimal? Well, as a fraction, that would be 1/100th. As a decimal, that would be 0.01. Okay? I'm just going to talk about these. I think it's going to, otherwise I'll be flicking backwards and forwards on the screen all the time. 2/5 of the class have gone to reading buddies. 43% are at a competition. Show how many children are left in the class as a decimal. So, 43%, we can change that. Well, it's up to you. You can keep that if you want to for now. We can make it a decimal because we need a decimal, so that'll be 0.43. Or we could just keep it at 43 for now. 2/5, a little bit of a test. Can you remember your fifths? It is 0.4 or 40. So, 40 and 43 is 83. How many's left to get to 100? 83, 93, 17. So what's the decimal? 0.17. 54% of the country have started growing their own vegetables. That's not true, I don't know. 0.2 of the country also grow flowers. Show the percent of people who grow veg and flowers. So 54% grow veg and 0.2 also grow flowers. So you want the combination of the two. You need to remember that that's 20, not 2. So that's 20%. So 74%. So 74% of people grow both veg and flowers. Number 5, 0.8 seeds grew. Show the percentages that haven't grown yet. You should know there's 0.2 left to get to 100 or the whole. And that as a percentage is 20, so 20%. Out of all the birds in the garden, only 34% eat the seeds. 43 hundredths eat the mealworms and the rest eat the fat balls. What fraction eat the fat balls? So let's keep these as numbers we can work with. So let's make that 43%. So 43 and 34%, so we know that, but we need to know what's left over. So if we add these two up, 43 and 34, 53, 63, 73, there we go, another 4, and then you just need to find what's left to get to your 100. Brilliant. And then your challenge was simply to make a few of your own. This would be really good if you've got slightly older siblings. I think they'll catch them out with some of these. Maybe you've got somebody at home, an adult at home who's been helping out a little bit with some parts of this, and you might want to make them a couple. It's completely up to you, or you can just make a few and see if you actually can solve them. Because I know some of you do these, and then you realise, oh, hang on, actually, I'm not going to be able to make an answer with this. So it's good to practice it. It shows that you understand the maths if you can then make your own. Okay, but brilliant, fantastic. Well done with that, guys.